Welcome to my simple tutorial on using SpringSharp. SpringSharp is a very simple and easy to use tool once you have the know-how that will allow you to generate reports of ships of a given characteristic. It's very handy and very nice to have on hand when designing ships. To start with, I will show you the output of the things you can generate. In this example here that I've completed earlier, I've done the gross occur first. After inputting all the parameters that I've extracted from Wargaming's 3D model, I was able to determine the characteristics of the ship in this report here. Now, I will be creating a brand new ship for this tutorial in order to show you a general idea of how you can use SpringSharp to create a what-if ship, so to speak. I'll start by selecting all metric because I'm going to be using metric for this example. You can name your ship whatever you'd like. I'm just going to name it example for this tutorial. It could be from any other country you like. We can say it's from Great Britain, for example, and we can make it any type we like. Let's just make it a battleship for this purpose. Ship laid down is the year in which your ship's hull was laid down. The later it is, the stronger your hull will be because ship construction methods got better as time went on. For this example, I'll just be using 1940. Engine built date is the date at which your machinery was constructed. Same with ship laid down date. Generally, the later this date, the better your machinery will be as far as specific power is concerned and volume is concerned. Specific power, for those who don't know, is how much power you get per unit mass of machinery. So as you go later in this date, you get a higher specific power output. For this purpose, I'll just be using 1942 as if the machinery was laid down, constructed at a later date to the hull. Dimensions, we can define our dimensions here. For this example, I'll just be using waterline length to define my ship. You can also define it with overall length. However, I'll be setting the length later, the overall length later. For now, I'll just be using a waterline length of 190 meters. Let's have a beam. Beam is how wide your ship is. At the bulges, you can define how big the bulges are for this as well. For example, if we had 40 meter bulges, then we would have 5 meters of bulge, or 2.5 meters of bulge on each side of our ship for the torpedo defense system. Draught is how deep in the water our hull sits. I'll just be saying 10 meters for this example, which is a fairly typical battleship draught, if I do recall correctly. It's about average. Displacement, we can set our block coefficient here, so basically how streamlined our hull is. A higher block coefficient will give a stronger but less streamlined hull. A lower block coefficient will give a weaker but more streamlined hull. You generally get less machinery space for the lower block coefficients and more machinery space for the higher block coefficients. And SpringSharp, when you move this slide, you can see SpringSharp will give you a output of displacement of how much your hull displaces. So for the time being, I'm just going to drag it until it's just under 45,000 tons. For this example. Sorry, I had a bit of a brain dead moment there. Next, we can go to our freeboard tab after we've defined all this. This is all we need here for now. Freeboard is where we can define the height of the hull out of the water. SpringSharp does this at 4 points along the hull. It does it on the forecastle, the forward deck, the aft deck, and the quarter deck. We can set the freeboard height for each of these. I'm just going to be very quick and general with this. I'm going to have a flush deck with a bulbous straight bow, which can be set here. You'll see the effects of this in a second, and we're going to have a round stern. Here we can set the angle of our bow, so let's just say 35 degrees. That's about right. And then we can have a 3 meter stern overhang. And you can see this brings up our overall length because we didn't define that. We defined length at the waterline. This brings it up to 200 meters. You can play around with that. It's not really. This is the parameters you would like to achieve. And this gives you a quick example up here of what your ship will look like. You can see with the bulbous straight bow, we've only angled the part of our freeboard out of the water, the part of our hull out of the water. With the other types, like normal type, the whole portion of the hull is angled. We can also have a bulbous forward bow, where we have a portion of the bow sticking forward, and a ram bow, which is the same sort of thing, really. But we'll go back to the example that I had earlier. This page basically complete. This is your freeboard is completely defined now. Next, I like to go to the engines tab. It's important that your ship moves generally. You don't want your ship to be stationary. And you can start here by defining your range. So let's define a 15,000 nautical mile range, and we can have a cruising speed at 15 knots. This will give us, well, this will enable SpringSharp to calculate the required amount of fuel in order to travel this range at this speed with the hull we have just defined. The next step is where we also pick our machinery type. So for this, I'm going to have oil-fired boilers with steam turbines, and I'm going to have geared drives. This gives the machinery a general way of working out what to work from. If, for example, if you're working from coal-fired boilers and complex reciprocating steam engines, they're going to be heavier, less efficient machinery in general. At this point, we should also give it some propeller shafts as well, because we can't transmit power into the water any other way without propellers. And at this point, we can start dragging this slider to select the max speed we'd like to achieve. And as we do this, you can see down here, SpringSharp is increasing the power requirements to reach this speed. So, for example, to reach 20.4 knots, we will need 40,810 shaft horsepower, and that's 30,000 kilowatts. It also gives you all the data for like wave resistance and your machinery weight and your bunker weight. So to achieve this range, as I said earlier, we will need a 4,295 ton bunker of fuel oil. But this ship should go decently fast, so we'll make it go 28 knots. And for this, we're requiring 142k SHP, which is, it's a fair decent amount of power. And at this point, we've completely defined a ship with no weapons, no armor. This is the minimum you require to define a ship. And we could generate a report from this, and SpringSharp wouldn't have any qualms. Here we can see our report's been generated, and there's no errors as of yet. We can probably tweak trim a little bit to bring up the seakeeping. But other than that, yeah, that's how a report is made. This is the most basic form of report you can generate. We have no weapons, no armor. We just have a hull with a set of machinery that is capable of doing 28 knots. Next, we should probably turn it into a warship for this example. So we'll go back to the Guns tab, and under the Guns tab there are several sub-tabs, starting with main battery all the way to fifth battery. We'll define our main battery. We'll have a pretty characteristical, a layout characteristical of a pretty standard battleship, shall we say. We'll have 16-inch guns, which you can input in millimeters or inches, by the way. We'll have 45 caliber length barrels. These are breech loading guns. This is where you can select this, by the way. Muzzle loading, quick firing, anti-air, DP, auto rapid fire guns, and machine guns, as well as your shells per gun and the shell weight. We'll have a bit heavier shells, I think. We'll have 1,200 kilogram shells, and we'll only have 100 rounds per gun because, let's be realistic. Then we can define how many mounts are 9 barrels, because this is the total number of barrels. We can define how many mounts this is in. So we'll have 3 mounts in turret on barbettes, which is pretty typical of every battleship after pre-dreads. I'm not an expert on that. Oh dear, making a fool of myself. On the next section here, we can define how many guns per turret we have. Technically, we've already defined it, but SpringSharp's a bit slow in this respect. So we'll need to define that we have 3 gun mounts here, and then we can have their position, which is shown on this example here. So center line ends 4 greater than aft, which means we have more of our guns forward than aft, as shown here. This grey area is bigger than this little grey area. So we have 2 guns forward and 1 aft. We will need one of them super firing, so above deck we'll need 1 mount, and this takes away from our on deck mounts of 2, because we'll have 2 of our turrets on the deck. That's our guns defined now, and now we can move on to their armor, because these will need armor. Turret and barbette mounts need armor, as SpringSharp showing a warning down here. So we can give them, for the initial purposes of this, we can just give them 380 millimeters of face armor. Other above deck is well, it's like turret roof armor, turret rear armor. It's basically the average of all the other armor on the turret itself. So for this, we can have like 155. That'll be pretty typical of turret roof armor of the day. Barbette and hoist is generally as thick, if not thicker, than the face or shield. Sorry, no, it depends on the design of the day, really. It's usually as thick as the turret face on the exposed portion of the barbette, and then usually thinner below deck, because you don't need to protect it since it's behind the belt. So we'll just keep this as 380, same as the face and shield. And that's defined our main battery now, so that we have a mass here. We have 1,028 tons per gun, and 3,666 tons per mount, with a broadside weight of, as shown here, and our magazine weight shown here. So that's 100 shells, 1,200 kilograms per shell. We can define our second battery now. We should generally have a second battery. Most battleships have secondary batteries. We'll also, actually no, we'll do 20 barrels. We'll do 5-inch guns. We'll keep them 45 caliber also for simplicity's sake. We can make these dual-purpose guns. There's no reason these can't be high-angle guns as well as surface engagement weaponry. Yeah, sorry, had a bit of a brain dead moment there. Shells per gun will probably be okay with 150, but let's increase it to 300 nonetheless. We'll leave the shell weight as SpringSharp has estimated. There's no reason not to change this for now. We'll have 10 mounts, we'll have twin mounts. We can put these in deck and hoist mounts, which is going to be a lot lighter than turret and barbette mounts. And we will have 6 of these above deck and 4 on deck, in a similar arrangement to like Alabama, for example, if I recall correctly. Although technically these shouldn't be on the deck. Okay, never mind, we'll just leave it like that. And these will be twin mounts, and they'll be on the sides and distributed evenly. This is fine as shown here. We can give them a bit of face armor, I guess. Let's say 25, like an inch. Why not? And that's our secondary battery defined. Now we can move on to the other tabs, because we don't really need any more batteries than that for now. We'll just for the simple example. The weapons tab is where you can define torpedoes, mines, mortars, and miscellaneous weights. Miscellaneous weights is pretty important because, as far as I know, SpringSharp doesn't simulate superstructure, so putting it in some additional weight here is a pretty good idea to also represent superstructure, as well as things like deck equipment and chains and etc. Just general things that SpringSharp doesn't take into account. So this is a pretty big ship, so we'll make this pretty heavy. We'll put 25 tons in each of these slots above the hull, so on the deck, above the deck, and in the void. We'll cover this void thing later. Oh, actually, no, we probably shouldn't put anything in the void. My mistake. We'll put the extra weight down here instead. And that's everything except armor now has been defined, so we're very close to creating a complete ship. You can also input armor in inches or millimeters. It allows you to choose this here. And on this page, because we've done the engines first, SpringSharp is kind enough to tell us the minimum belt length to cover the machinery and magazines, because it has calculated how long those will be when they're all lined up in the arrangements that we've put them on in this page here. So that's very nice for SpringSharp. Hitting the default button here will set the lengths of your belts to your freeboard. So the distances in here, we have 30 and 35% here. So that's 65% of your waterline length is going to be the protected area. SpringSharp only lets you SpringSharp allows you to armor other parts of the ship, but the main belt and the upper belt are always going to be within these two markers here, which is your forward and aft deck. So that's how you can define this length, and hitting default will set it to how long those are. Ends is just basically how long the ends of your ship are. This distance here, for example, is this parameter. Height is obviously how high these armor belts are. Main belt incline is how inclined, how angled the belt is. You can have a angled belt; it doesn't hurt anything. You can add 10 degrees here. For our main belt, we'll go with the same thickness as our turret faces. We'll go 380. We won't have armored ends or upper belt. We'll go with an all or nothing design here. Bulges is there's a handy shot. I forgot to show you this. There's a handy image down here to demonstrate what you're putting in here. Bulges is this section here. So this is the skin of your torpedo defense system. It can basically be, if it's 0, it's basically just the same thickness as your hull. There's no thickness increase here, as far as I understand it. And the length here also needs to be defined. Usually it's as long as your main belts, like such. And it can be as high as you would like it, but realistically you don't want it to be much more than your draft. So 9.37 is a good number because it comes from the torpedo bulkhead default setting that SpringSharp uses. So we can leave the bulges blank. We'll just use the standard skin of the ship to be the outer portion of our torpedo defense system. We can have a torpedo bulkhead, however. We'll have a 50mm bulkhead, and we'll have additional bulkheads rather than strengthened bulkheads. The difference can be shown here. Additional bulkheads are new bulkheads that are added in between your inboard bulkheads, and the strengthened bulkhead would just be the regular bulkhead with this number here added to it. And then we can define the beam of these bulkheads. So the distance apart between these two, it can't be more than your hull beam, and it needs to be less than your hull beam ideally, because you want space for your torpedo to explode in. You want to avoid space for the incoming torpedo to explode into without damaging your ship. So it should be less than 35. We'll make it 30 for now. We already have a bulge beam set, so we've got additional 5 meters here, and then we've got an additional 5 meters here. So that's 5 meters on each side of the ship now that we have for the incoming torpedo to explode into. Now we can define our armor deck. We can have forecastle and quarterdeck and fore and aft deck armors. Since this is an all or nothing armor scheme, we'll just put some armor into the fore and aft deck. We'll have 155 millimeters of deck. Let's make it 150. Yeah, we'll have 150. You can select the type of armor deck here. You can have a armor deck or a protected deck. A protected deck is essentially turtleback. Armor deck is just a simple roof over your belt, over your machinery. And then you can have a box over your machinery, a box over magazines, and a box over your machinery and magazines, which is essentially just a box in this area here protecting your vitals. It's sort of pointless though, considering we've already got a belt and whatnot. So we'll just have a single armored deck. We'll have a main armored deck. And next, conning towers. We can define the conning towers. We'll put the forward conning tower at 380. We could have a protected aft one, I guess, at the 150 millimeters. And with that, we are actually complete. So we've completely defined now the parameters necessary for a warship, a battleship. And at the end of this section here, we can take a quick look down here. Everything's okay, we haven't missed anything. Composite strength is the default thing that SpringSharp shows, and it's 1.08, which means that our ship hull is sufficiently strong enough to support the masses and equipment that we've inputted into it here so far. Next, we can take a quick look at the Performance tab, and this will give us a general idea of the performance of our ship, so we can gain a bit more seakeeping here. I should explain actually, seakeeping in SpringSharp is measured at your top speed, so it's literally measured at 28 knots. We have 0.9 seakeeping, and it's sort of an arbitrary rating, but SpringSharp would say anything below, you can see the little pop-up here, anything below 1 is poor, anything below 0.7 is a really bad sea boat. But since it's taken at top speed, ships don't sail at top speed in storms anyway, so this is fine, really. The other important factors really are stability. You don't want this to be below 1.0, otherwise your ship's going to be unstable. It needs to be above 1.0 or 1.0 at the very minimum. Using all the other stats, SpringSharp gives you a general idea of how many hits your ship can take from its main battery, so 34.1 hits from its own guns. These are non-critical penetrating hits, so they don't have to hit machinery. This sort of simulates like holing created by shell pass-throughs and whatnot. It can go pretty in depth. Torpedo hits. This is usually very optimistic. You could maybe consider well, 12 torpedoes is a bit ridiculous, really, in any circumstances. But it gives you it puts it there for a general idea, really. It's not the most accurate thing in the world, but it's handy, I guess, sort of, maybe. It's SpringSharp. That's the one thing SpringSharp falls down at, really, among other things. Then it tells you how much space you have for your machinery and accommodation and workspaces. It's a bit counterintuitive. For machinery, storage, and compartmentation, a lower number is better, but for accommodation and workspaces, a higher number is better. So both of these are superb on this ship example. And then it gives you a breakdown of displacement, cost, and strength, etc. It gives you displacement at light, standard, normal, and maximum. Your hull loading, a cost estimation, and sectional strengths. So cross-sectional strength, longitudinal strength, and composite strength. This number ideally should be above 1. In an ideal world, it wants to be 1 and nothing less and nothing more, because you're eking everything out of your design in that way. And now that we've got a complete design, we can start tweaking it. I will show you how I like to tweak designs. So we can start by optimizing this heavily. We don't need a belt or a protected area this long whatsoever. Our protected area only needs to be 98 meters. So we can reduce this heavily, and we can go to freeboard. Well, actually there's two ways you can do this. You can reduce it right here, change these numbers right here, or you can change the protected area in freeboard here itself. I like to do it this way. I guess it's just personal preference, but we'll reduce this and increase our quarterdeck and hit default again. This is to decrease it to 114, so we can go even more. We can have an even longer forecastle. This might be too much. Yeah, this is a smidge too much. So we'll reduce this some more. By the way, I'm changing quarterdeck because you can't change aft deck. It's simply what remains of all of the others. So I'm changing quarterdeck to effectively change the aft deck. And we can hit default again. Okay, yeah, so now we have a belt that's just long enough to cover our machinery and mags. This has saved a lot of weight. But we can save even more weight because SpringSharp usually has a little bug. Yeah, you see I selected the same thing again and we lost weight here because this doesn't update in SpringSharp, or the version I'm using at least. So we've just updated that, and now we've gained a huge amount of strength, which is great. We can spend it, or we can spend it on other things. We can spend it on more armor, or we can just simply decrease the mass of our ship. We'll try that actually. Word of warning though, decreasing your block coefficient will decrease your volume for machinery. If we go from 0.586, if we go down until our composite strength down here is 1.0, you will now see that our required distance for our belt is gone up. This is because there's less room for your machinery because your hull's more streamlined, it's more cut away. So this is already at the max because I adjusted freeboard earlier. So now we need to go back into freeboard and we'll just turn this down a little bit more and hit default again. And now here we're back to fine again. So this is perfect. This is totally okay. Oh, no, just slightly too weak. Okay. Increase ever so slightly. There we go. So now we're at 1.0 strength and everything is fine and dandy. Go back to performance. You can see how things have changed. Gained a little bit of... we don't need as much trim anymore because of our changes we've made. And we can hit make report. And we have a fully fleshed out report. This is the process I go through for designing a ship. At this point you can save it. Name it whatever you'd like. And open it up and review the report whenever you would like. You can copy this into a text file and do what you'd like with it. But yeah, this is the process I use for designing a ship in SpringSharp. I hope this was somewhat helpful. I'm sorry for my my incompetence. I have no clue what I'm doing. Really, you shouldn't listen to me. But yeah, I hope this was a help, and thank you for watching.